Okay, so review. So if I wanted to find the volume or the area of that shape, and then I want to convert that area into a volume, how would I do it? What calculation would I do? Integral. So you said pi, okay, from A to B. F of x squared dx. Okay. Pi r squared. That's all this is. Okay, instead of doing a disk, we have a washer.
It didn't say anything about being PDF already, so I didn't find anything to change.
Because it was over on the right where it says PDF and TIFF.
Oh. So, am I going to have to do it again?
Probably.
Okay.
That's
okay,
right.
so it's on the right, it says PDF and TIFF?
Yeah.
And you want it to be a PDF?
Yes, because then I don't have to convert it. So you have two functions. No, well, I'm just being silly. They don't have to look the same. They could look like this. There. There. It's a whale. We're whale watching. So we talked about this one this morning. So we're going to do we could do the integral of the bigger one minus the integral of the... I'm just looking at it. So you could do the integral from a to b of f of x squared dx minus the integral from a to b of g of x squared dx. That was one way of writing it. What was the other way? Yeah. So f of x squared minus g of x squared. And I'm running out of room. So it has to, it just comes down to the fact that if you've got the work done separately, if somebody has made you already do that, somebody's already made you do that, then the area between them, or the volume of the washer or the whale, or the way I've drawn it, is easy to do, just subtract them. But if somebody doesn't give it to you, then I probably would choose to do it the way on the right, because I can do some simplification and only have to do one antiderivative. Yeah? Yeah, there's a dx at the end of that, but I didn't have room. I guess I can make room. Oops, well, stuff's going to move. Oh well. There. Okay. Now, instead of around the x-axis, now around the y-axis. So, taking that shape, what? It says find f of y around the y-axis. Yeah. It's because the typing is screwed up. Yeah. So how do you find if I ask you to rotate that around the axis, how do you find its volume? And then if I have two functions, Sideways whale. So how do you do that one? Pi minus the integral from a to b of f of y squared minus g of y squared dy. I don't know. It depends if somebody gives you the information. So this was on a AP exam. Let's do it together as a group. The region bounded by the curves e to the x and e to the negative x is rotated about the x-axis to generate a volume of solid. E to the x looks like this. E to the negative x looks like this. It's rotated around the x-axis. To generate a solid. Ooh, that's kind of sneaky. Yeah, because we're going to integrate from negative infinity to positive infinity. That's all right. So pi minus. So what we need to do, so we need to do this in two parts, do we not? Need to do this part. Negative infinity to 0. Yeah. Yeah. I'm scared. Like, what am I doing wrong here? Is rotated around the x-axis to generate the region bounded by the curves. Yeah, I guess. Yeah. No. No, usually we enclose it. Usually there's another line somewhere to completely close the curve. Yeah, like y equals 0. What? Yeah, well, it's a good question. Okay, so we're going to integrate from negative infinity to 0 of e to the x squared dx. And we're going to add to that area the integral of 0 to pi, or 0 to infinity, of e to the negative x squared dx. Okay, what can we do with that? What? Well, you could do this. Yeah? Now, does anybody remember the antiderivative of e to the kx over k? E to the kx over k. Yeah. Because there's not... Right. Yeah. See, I thought that was strange. What I was really expecting to see here was then the bounded in a line here, and then to take that blue area and rotate it and do one minus the other, but that's not what's happening here. Unless I'm completely misunderstanding the question. The region bounded by the curves and y equals negative x is rotated about this axis to generate. That's yeah, well, there's no third line to enclose the area to tell us what area we're talking about. So we're assuming that it's the x-axis. Okay, so we just talked about what the antiderivative of e to the kx is. It's e to the kx over k. Okay, so we're going to substitute infinity in our head. You kind of have to do this just sort of thinking about the size of numbers. So you have e to the 2 times 0 over 2 minus e to the negative infinity over 2. 0. E to the negative infinity is 0. So that one's done. Plus e to the negative e to the 2 times negative infinity over negative 2. Zero again. No, not the next one. And then you're going to have a minus, and then you're going to substitute 0 in, and you're going to have negative a half. So you have pi times a half plus pi times a half. So it's just pi units. Whatever. Yeah. E to the 2k over, you know, e to the kx. The antiderivative of e to the kx is e to the kx over k. The derivative of e to the kx is e to the kx times k. You have to recognize you can't substitute infinity in, you just have to think about it, blah, 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 blah. Okay. Find the volume of the solids generated by revolving y equals x squared x, the y-axis. So we did this morning. There's y equals x squared, there's y. So I want to take the inner around the y-axis. So I need to find the intersection points. So you could do 2x equals x squared, 0 equals x squared minus 2x. But that's not what I need to know. Because we're rotating it around the y-axis, we need to know our y-coordinates. Well, I would just, it's pretty reasonable to find y pretty fast now. So we're going to integrate from 0 to 4 of the farthermost right one minus the not as far right one. And they have to be y, they have to have y's in their formula. So take, which one's farther to the right, the blue curve or the black curve? The black. The black curve. So how do you write the black curve as x equals? What? Yeah, but in the intersection, we're talking about in the bounded area here. So we're going to take that shape and spin it. Square root of y, yeah.
Okay, so it would be the second one.
Okay.
Do I need a letter for the
No.
No.
Well, yeah, but just have her email me.
Okay.
So the square root of y, and then solve this one for y. Solve the blue one for y. Y over 2. Okay, so clean it up. Pi. Yep. Oh, where's the square root of y coming from? We're taking this equation and making it x equals. So So pi 0 to 4 of y minus y squared over 4. So the antiderivative from 0 to 4 of that will give you the volume. Oh, put a pi in front. So you put 4 in for y, you put 0 in for y, and you subtract your answers. Yeah? 16 over 2 minus 64 over 12 minus 0. So what's 60? I don't know what 64 twelfths is reduced. 40, 32 a sixth, 16 thirds. So 8 minus 16 thirds. I don't know, 3 goes into 16, 5 and a third. So 2 and 2 thirds. So 2 and 2 thirds, 5. What's that? Oh, okay. So, not that bad, right? It's just the farther to the right minus the farther to the left. But we're rotating around the x-axis and the y-axis. Now, the only thing that's new in the AP course in the last little while is we have to do lines that are lines that are parallel to the axes. So not just the x-axis, but the line x equals 1 or the line y equals 1 or the line x equals 2. So graph y equals x squared below and pick a point x, y. So let's do that. Right there. Now what are we going to do? Consider distances from the point to the lines y equals 3 and y equals 1. Oh, negative 1. Sorry, you're right. Y equals 3. I'm arbitrarily putting x, y there, but it doesn't really matter. Okay. How do I find the distance from the blue line, from the blue point up to the black line? Like, if y is 1 unit, if y is 1, then the distance is 2, 3 minus 1. What about this one? Let's say y is 8. How far apart are they? 9. How can we get 9? What if y is 3? What's the distance? 4. Okay. Y plus 1. Is there any other way of getting it? What? Negative 1 minus y. Y minus negative 1. Sure. Okay. What else? The lines x equals 2. Well, it's going to be really hard to put on here, but the line x equals 2. So here we are. Here's the line x equals 2. So how far? Yeah, but we're just arbitrarily drawing it to help you see. So we're talking about this distance now. So if x is 0, the distance is 2 minus x. And what about at -2? X plus 2 or x plus or x minus -2. What? What? Why are we doing this? Because we're going to take the curve and spin it around lines now, not just the x-axis and the y-axis.
So we should draw this line?
You know what? I don't know. I don't know if you need to. I'm just going to talk about, well, you'll see. Flip the page. You'll see. So, I want you to graph this though first. Everybody graph that curve and this line on your page. So 2 minus x squared looks like that. The line y equals 1 looks like that. So what I want to do is I want to take this yellow area, and instead of spinning it around the x-axis, I want you to spin it around that purple line. It says bounded by. So that means as soon as you find the closed off region, that's what we're talking about. Okay? As soon as we find out the closed off region. So what we need to do is we need to talk about how far it is from here to here. That's why I was asking about distance. So which ones? Okay, so we need to do 3 things. 3 things? Can somebody tell me one thing we need to find? Sure. What else do we need to know? The intersections. So we need to know those points. And we need to talk about the radius. Yeah. So can you talk about where this point is? Can you find it for me? Pardon me? Yes. What else do we need to do? We need to talk about the radius. So how are we going to do that? What is it? That's one radius. What's the other radius? Well, no, no, just like we're spinning it around. We're spinning it around that blue line. No. There's only one radius here, folks. I think that's what you're. I'm just thinking about this. There's only one radius here. Yeah, it's just going to be. And I'm just looking at this because I don't want to screw it up because it's been such a long time since I've done this. Yeah. So which is higher? What you got to do is talk about this radius. Call that r. So you got to talk about the distance. This is why I said, should we write down the distance? You got to talk about the distance from here to here. It's going to change. It's going to change, right? Anywhere between -1 and +1. But we know the blue graph is higher than the purple line throughout. But if I was right here, let's say if I was right here, we know that the y value here is 2. What's the distance between the y and y equals 1 and the y coordinate 2? How did you get that? 2 minus 1. Okay, now it's just 2 minus 1. Do it algebraically now. I'm at any point that has a y coordinate 2 minus x squared. What's the distance from the any point 2 minus x squared to the line y equals 1? 2 minus, so that's the radius. So this is the radius, the distance between the curve and the line that we're rotating it around. We did that. Just a sec. Now you're thinking to yourself, that doesn't make any sense to me. Just pause. Everybody pause. I'm going to go to Neverland. I'm going to think about this. Let's say we do this curve, y equals 5 minus 25 minus x squared. And I ask you to rotate it around the x-axis. So you're going to go, okay, Mr. F, I'm going to put pi here. I'm going to integral. I'm waiting for my computer to catch up. Pi integral from 0 to 5, because I only want you to do this part. F of x squared. So 25 minus x squared dx. We just talked about this, and you guys are okay with that. But what was missing in this formula, and it makes no sense for me to introduce it this way, but what was missing in this formula it's the distance from the point on the curve to the line that you're rotating it about. Well, the distance, it's minus 0, because the line has a y value of 0 there. But as soon as I make the y and y value 1, all I do is this. If it's the line y equals 2, 2. If it's the line y equals 10, it's up here, and all of a sudden, the order flips. Oops, I don't need the squared there. Yeah. You'd get a negative answer, though. I would be careful. But do you see what's happening now? It's just the same thing again, except for the line isn't the y-axis. On the y-axis, it's just blah minus 0. But here, it's going to be, is it minus 10 or is it 10 minus? And it just depends who's higher. Geez, that sounds familiar. Okay. Your brain hurts? Okay, we'll finish this page and we'll stop. No, I think we should stop after this. The region is bounded by the curve y equals x squared, x equals 0, and x equals 2. So let's draw that. So there's y equals x squared. The line x equals 0. And the line x equals 2. So it gives us this stuff right here. Yeah? What else do we know? And we're rotating it around the line y equals -1. Y equals -1. So we're going to spin it around that line. So, integral from where to where? 0 to 2. So we'll put a pi here. Pi. And then we'll go 0 to 2. Now, we need to be careful. We need to talk about, there's two radiuses we need to talk about. Maybe we shouldn't do it in both in the same color. So we're going to do the radius of the bigger one. So how far is it from here down to here? How do you get that? X squared plus 1 squared. So the radius of the bigger one minus the radius of the smaller one. You know the radius of the smaller one. It doesn't change. It's always... How far is it from here down to here? What? 1. So minus 1 squared dx. I would use my graphing calculator to do this. Okay? Because you don't know any substitution technique to do this one. So you would see me put this in y1 in my graphing calculator, put that in y1, get an answer, and then multiply it by pi. Please do that. By pi. Pi, sorry. I meant to say pi. If I said 5, I apologize. Okay, last one. We're stopping because I'm sensing lostness. Okay, take the same thing and rotate it around the y line y equals 4. So I'll just draw the little bit of the curve again. And the line y equals 4. Now you're going to do the radius of the bigger minus the radius of the smaller. Pi 0 to 2. Which one's the bigger now? This distance is the bigger distance. Pardon me? The farther, good call, farther distance. Fine. Doesn't really matter, but okay. So 0 to 2, always the bigger distance first. So the bigger distance is this one. That's the bigger radius. So 4 squared minus the smaller one. So you got to talk about how far this is from here. 4 minus x squared, good, squared dx. And I think this is a good place to stop. Yeah? I think so. Okay. Well, maybe if I... So what I'm saying is, okay, so what I'm trying to do here is we've got a line, and we've got a curve, there, a curve that looks like this, and it starts at some coordinate A, and it goes to some coordinate B, and it's got a y-coordinate f of x, and I want to know what the volume is that is as you rotate it around that axis. So I need to think about, I always need to think about where's the bigger radius. Yeah. You have to visualize this as a piece of a washer. You know, like at home when you're putting over the. So you always have to go, okay, which one's the bigger distance? That one's bigger, so it's going to be so it's going to be some y value, L minus f of x squared. That's going to be your larger radius, and you always want to minus your smaller radius. So that would be just here, it would just be L squared. And you would integrate from A to B. But that's when the line is above the curve. When it's the other way around, what happens? Yeah, they're going to switch places. Does it always have to be like that? No, it could be. It could be. Okay, let's see if you guys can figure this one out. Are you guys knowing what I'm doing here, or am I just making noise? You like to think you get it? Okay, so I want you to take that little strip of yellowness and rotate it around the line L. Let's make it the line y equals 6, just so we don't use L to scare you. So we're going to go pi integral from where to where? A to B. And we need to put two things in our brackets. The one radius squared minus the other radius squared. 6 minus f of x and 6 minus g of x. Yeah? That's all it is. That's all it is. F of x first because it's farther away, and when it's farther away, it creates the outside of the washer. Right. Does that make more sense to you now, Andrew? Okay. So Andrew's proposing that I blow all of your brains away and rotate it that way. Yeah, you could, but then it would be, instead of 6, it would be k of x minus f of x. You're right, but oh man. Not in this course. I don't even think I ever talked about it, but you're right. Second year, you'd start to do weird kind of things like this. But are we okay with what's happening here now? Do you want a sideways one, just in case? Like if, here, let's just see if you can do this. See if you can think your way through this. So here's the line. Here's the line, x equals 2. And over here we have, I don't know, A, B, okay, I want this area, but it's spun around the line x equals 2. Sorry. There. Okay, what calculation would you do here? Minus. Good. dy. Are we better now? Okay, I'm stopping. What can you work on? You can work on whole, yeah, you got that assignment to work on. You got all your, if you're following along in your textbook for in terms of homework, thank you for annoying me. Hey, shh. If you're trying homework, practice questions in the homework, you can look at hey, folks, you can look at everything that involves 7.2 now, and you can do parts of 7.3, you can look at questions after number 13 in 7.3. You can look at those now. Okay, I'm stopping.